Hi everyone, so today's SAT prep lesson with Coach Fred is going to be on exponential functions. So this is the introductory video, so think of it as video 1. There's going to be a few additional ones that go along with this, as well as some practice. So our objective is really to make sure you understand what an exponential function is and what the graph looks like. Now, you don't have to graph on the SAT, but you do have to understand the exponential function. So in your classes, you learned that the exponential function have a form y equals ab raised to the x power. And all a, b, and x are real numbers, okay? I'm actually not going to go over the domain and range because I don't think you really need that for this. But I am going to talk about what you do need to know. So the two basic functions, the one I have in blue here and the one I have in red here, are exponential growth and decay. So this is a picture of growth, and this is a picture of decay. And fundamentally, when you look at the function, like f of x equals b to the x or y equals a b to the x, if b is greater than 1, where b is greater than 1, it's going to indicate that you have exponential growth. If b is less than 1 but greater than 0, so it's a fraction less than 1, then you're going to have exponential decay. And so you learn to graph these, and what the test likes to ask you to do, though, is to identify from a table what would be either linear or quadratic or exponential, or to write an equation given some factual information, or to interpret different parts of an exponential model. So we're going to look at those models, but today what we're going to do is go over what's the difference between linear and exponential. So what is the difference between linear growth, exponential growth, or linear decay and exponential decay, and how are you going to recognize it? Well, we need to remember that a line, a line moves at has a constant rate of change. A constant rate of change. Now, this is a positive. This line has a positive slope. It also could have a negative slope, which would mean it would be falling. But that rate at which it changes is constant. Okay, the speed at which it is growing is constant. Exponential growth, even the graph looks different. There's a point where we could say maybe, it's growing kind of linearly here and a bit linear here, but there's a point if you put it all together where this graph grows really slow and then all of a sudden it kind of shoots up. And its rate of change is that of a ratio or a percentage, okay? So changes by a percentage, which means that terms are going to have a common ratio. Whereas with a constant rate of change for linear, they're going to have a slope, a common slope. Okay, so you're going to want to also feel comfortable with recognizing the difference between a linear, a quadratic, and an exponential model. If you've been watching my videos, you know that for me, I always look at functions and equations, and I always want to identify what they are first. And usually, it's the exponent that can tell me. So, for example, if the highest exponent of x is 1, then it's linear. If it's 2, it's quadratic. And if the highest exponent is a variable, if the exponent is a variable, then it's an exponential function. And yes, you should ask yourself, does it have the form of a linear, of a quadratic, of an exponential? So here we've got this equation, y equals 10 times 1/3 raised to the x power. So that takes the form y equals ab to the x. The exponent is a variable, it's exponential. Whereas in 2, I look at it, my highest exponent of x is 1, and that actually takes on the form of a linear equation, y equals b plus mx. Now, remember I said that the SAT likes to play around with that because you're used to it as y equals mx plus b. Means the same thing, just look at where your x is, okay? This next one, if I'm looking, I look at that highest exponent, it's 2, quadratic. 4, look, even though there's a negative number, my highest exponent is 1, so it's linear. All right, 5, y equals negative 1/2, 3 to the x. The exponent is a variable, it's exponential. And then the last one, looking at it, I've got the highest exponent being 2, which tells me it's quadratic. All right, guys, so that's a quick introduction review of exponential functions, but you are going to want to watch the next couple of videos when I go into detail on the equations and how to tell the difference in a graph, in a table. Okay, have a great day.